Now next thing, next law, I would say next law. We have completed this polygon law. It's a time to move on. It's a time to move on triangle law. Triangle law. Yeah, we started to discuss vector addition law with this polygon law. Then now we are going to move on triangle law. Then we will see parallelogram law. Okay, triangle law, parallelogram law. Let me erase. We didn't finish this parallelogram. Just we saw it as a dramatically, not mathematically. We will complete this polygon law mathematically in later part. Triangle law. How does a triangle look? How does it looks like this? It can triangle can be like this. It can be like this. Okay, so our focus on not. I am saying only we need how much vectors? Three vectors. Only three vectors. Not four, not two. Three vectors. So third will be our resulting vector. Third will be our resulting vector. So triangle. Let's us say it dramatically. Later we will say it mathematically. Let's say this is a one, and another we have this. Can we complete this by using triangle law? Yes, we can. So remember, you are going to draw resulting vector, third vector. There are some points, some important points that we have to follow. What are those points? Those points are, look at these two vectors. Uh, they are connected correctly. Yes, they are connected correctly. You can draw third vector. You can go draw the third vector. Now next point is you will have to say order pair. From where would you start? This will matter. Order pair. For example, we another is like this. Will you start to draw? Will you start drawing the third resulting vector from here? If you are drawing from here, what is the logic behind it? If you are drawing from here, what is the logic behind it? This logic is known as order. Order. So remember, it is going like this, then again this, but we will not start now. Opposite of this. We will have to start to draw resulting vector opposite of this. It is going like this. Hmm, hmm, hmm. Now this will we will start from initial. From initial. This vector. So this will be known as vector. Okay, so this C, it can be our resulting vector. It can be our resulting vector. It is written as like this. Vector A plus vector B is equal to vector C. We are adding, not subtracting. So this plus this, we will get this hypotenuse, which is resulting vector. This is the hypotenuse. So vector A plus vector B is equal to vector C. It came by using triangle. Now next. we have this P and Q. What would be resulting vector? What would be resulting vector? So our resulting vector would be, it is going like this, from here, then again from here. So we will not go like this. This will be incorrect. We will have to start from initial. We will have to start from initial. So this is an initial, like that. This is the correct way. So this third will be our resulting vector. Third will be our resulting vector. So resulting vector of P and Q would be vector. Would be vector. I hope you are understanding. Next we have this. Next we have this. Let's say it is a C and this is a D. It is going like this. Head to tail. All this two actors are connected head to tail. Head to tail. So here it is going like this. Then we will not draw resulting vector from here. No, it will be incorrect. This is a wrong order. So order would be like this. Head to head, tail to tail. Head to head, tail to tail. So this will be our resulting vector. Okay. A resulting vector of C and D is a resulting R. Vector R. Vector R. Vector R. Now, let's take another question. You will observe that the resulting vector is connected head to head, and tail to tail. That point you will observe. And third point, next point is given vectors will be connected head to tail to head. But resulting would be connected head to head or tail to tail. This point you will observe. This vector, vector A and vector, both are not connected by the Kirchhoff. Both are not connected. Both are not connected. And then we have this vector B. And question is asking, solve this, find the resulting vector by using triangle, where these two vectors are given by the question. Find resulting vector. Now we can use shifting method. Shifting method. Any of these two vectors you can shift to connect both, to connect them. For example, this is like this. We are shifting this, so it will go like this. No, like that. We just shifted. It went over. So this is A and this is B. You can see it started from here and it is ending over here. From here to here, then again. So all these two vectors are connected head to head. So third would be third would be, yes, third is correct, like that. Third is correct. So this is our resultant one. So R vector is equal to vector A plus vector B. This R In the case of a triangle, this is our hypotenuse. This R is a hypotenuse. That's why we are saying vector A plus vector B is equal to vector R. Okay. You can shift if two vectors are given as separately. Then second is draw vector A plus 2 vector B. Question is like this. Figures of vectors A and B are not given, but you can draw. Let's say vector A is like this. So double of vector, if this is like this, if it is like this, vector B, so double of this would be this much vector B, 2B. Now this will go over here, and second will come, which is 2B, and this is A. So resulting would be like this. This is our resulting. So resulting for this vector A plus 2B vector. This is our answer. That is how you will convert any given vector into 2 times, into 3 times. Now next, draw vector A minus vector B. This vector A minus vector B. Another vector is nothing but negative vector. This B is a negative vector. This is A. This is A. If figures of vectors are given, which is like this, it is like this. So you will have to convert. This is not a minus B vector. You will have to convert into negative vector. So this will be like this. Direction will be opposite. Magnitude will be same. Now it is a minus B vector. Okay. If it was already given by the equation there. Now here, as you can see, this A vector and this B vector. This B vector. So resulting would be this vector would be resulting vector. This is minus is equal to A minus B vector. Okay. For example, if you did not understand still, then okay, let me explain again. This is a given vector. This is a given vector, which is a C. It is not negative C. This is a positive C. Positive C. Now question is asked. Question says that tell me what would be negative C. Negative. How would negative C vector? How would C vector look when it comes to negative of a C vector? So it will look like this. So direction it will be in this. So this will be, so magnitude will be same. Now this became minus C vector. That is how you will convert. Now this part is also done. We saw it dramatically, not mathematically. We will see it mathematically in later part. Now let's see parallelogram dramatically. Parallelogram law. There can be three vectors, two vectors. Let's start it to understand it by taking three vectors. We have this, this, and this. Vector A, vector B, vector C. Vector A, vector B, vector C. Question is saying convert this into parallelogram law. Solve this by using parallelogram. When it comes to parallelogram, it looks like this. It can look like this. There would be four vectors. Already we have this. Already we have three vectors. So this C is our diagonal part, diagonal vector. I would say diagonal vector. When it comes to parallelogram, we have to shift something. So we have to shift any vector. Then we will get parallelogram. If you shift this or if you shift this, any of these two vector, you will get parallelogram. I am going to shift this over here and this over here. This over here. Remember, this C is our diagonal. We are going to shift this A vector over here and this V vector over here. Now we will get parallelogram. Parallelogram which means there are four vectors including diagonal vector. So this is our A vector. Not A but B. We shifted this P without changing its direction, without changing its magnitude, which is valid. This A, and it is our. This is our okay. No, it can be shifted over here without changing direction and magnitude. This P. It's our complete. We have done it completely. Our work was just to shift two vectors so that we can get parallelogram diagram. Now it is looking this one, 2, 3, 4. 3, 4. If you shift this over here and it is like that, then it will be invalid because we changed what? We would have changed direction. That's why it will be invalid. We shifted this to two vectors without changing its direction and magnitude. That's why it is valid for this question. That's it. It was about parallelogram. So remember, let's say this is our diagonal vector. So D, it is equal to vector A plus vector B. You can say this is equal to A plus B. This is equal to A plus B. where length of this parallelogram, which means length of a parallel lines, are equal. If length of this vector is 6, so this will be also 6. If this is a 5, so this will be also 5. This is the meaning of a parallelogram figure. Parallelogram polygon. This is the meaning of a parallelogram polygon. Okay, so this that vector is equal to this vector. Okay. Now there are two diagonal. One this one, another one this. It is just opposite of this. This is just opposite of this. So that's why diagonal 2 will be equal to vector B minus vector A. Vector B minus vector B minus vector B minus vector A. How did it come? Now question is how did it come? Here we are saying that this is equal to this. Vector A plus vector D is equal to this vector B. Now it will go this side, vector B minus vector A. That is how it came. This plus this, vector A plus vector A. This plus this. Okay. This is a diagonal 2. Diagonal 1 was vector A plus vector B. Vector B. Vector B. Now next thing, we have completed discussion of triangle law and polygon law and parallelogram. We saw all this dramatically, not mathematically. Not mathematically. We have separate part for this mathematically. Now we are going to the next point, which is how to find magnitude of any vector. Let's see. Let's see. This is our question. Look at this. Analytically method to find. This is an analytically method to find the resultant of two vectors. Resultant of two vectors. This one vector and this another vector. So resultant of this vector is vector C. This vector C is a resulting vector, which is the third vector. My question is how to find magnitude of a given A vector. So just you can use this mode with a given vector. So here mode of this vector, it became magnitude. It is equal to now this A. A is a scalar quantity. Now it became a scalar quantity. We used to only mode. It is used to remove a direction. Okay. Now magnitude of this vector, it can be written as mod of this, and this will be equal to B. This will be equal to C. What do you understand by resulting of vector? So resulting of vector, for example C, it means we are saying this is equal to sum of A vector and B vector. Both are different. Resulting vector, which means sum of two vectors A and B. It means we removed direction. If you want only magnitude, not a direction, then you can use a formula. This is equal to A plus B A square plus B square plus 2AB cos theta. Okay, so there is a formula. Of course, you are finding magnitude. So A square plus B square plus 2AB cos theta. This is formula. There is a derivation. We will talk about it. Just right now understand this is a formula to calculate magnitude of any vector. Mathematically I am telling you. Dramatically I have told you. But what about mathematically? To find any resulting vector mathematically, we will have to use this formula. So this it is not vector. This is magnitude. Okay. B square. A square plus B square plus 2AB cos theta. Okay. So this angle will be nothing but angle between two vectors. Angle between this vector and this vector. As you can see, this is our theta. What if we want theta which is inclined by a resulting vector? So we are talking about this. We consider it as a alpha. So this tan alpha will be nothing but this B upon, according to this theta, this is a perpendicular and this is a base. So this upon this, yeah, there is a derivation to calculate. B sine upon A plus B cos theta. A plus B cos theta. These are two formulas that will help to solve a lot of equations. There are a lot of equations based on these two formulas. Now, when to use this formula and when to use this formula? When question is asking what is the angle which is angle between resulting vector and a given vector. Okay. For example, This is C. We are considering this vector C as a resulting vector. So question is asking what is the angle between this resulting vector and to vector E. In that case, we will have to use this formula. So this angle, which is nothing but between resulting vector and a given vector. Okay. Okay. Done. Okay. Done. So this is considered as a sine and this is considered as a cos. So B cos B is sine theta upon A plus B cos theta. A plus B cos theta. We are talking about this theta. Okay, this theta. So A plus B cos theta. Okay. Now, when to use this formula? We will use this formula when we want only magnitude. When we want only magnitude. Okay, magnitude. Then it will be used. This formula will be used. So to get only magnitude, just under root of a square plus b square 2ab cos theta. 2ab cos theta. Tan alpha is equal to b cos theta upon a plus sin theta. So b sin theta, b sin theta. This is b sin theta plus b sin theta upon a plus b cos theta. These two formulas will help you a lot. Now let's say derivation behind it. What is the logic behind it? What is the logic behind this formula? Behind this formula. Let's see. Let me write. Logic. What is logic? Logic. What is the logic behind it? Now we want to know what is the logic behind this game. A vector plus b vector is equal to c vector c. Look, we are going to say logic behind this is c is equal to under root of a square plus b square. Hold on, a square plus b square plus b square plus 2ab cos theta. Cos theta. Okay. What is the logic behind it? That is what we are going to say. Now another formula to calculate this alpha. So tan alpha is equal to uh, b sine theta upon a plus b cos theta. There are two formulas. What is the logic behind these two formulas? How did it came? How did it come? How? With the help of this figure, we will be able to find. Now let me draw again. Look at this is one vector. There are another. This one another, and this is a resulting vector. This third is a resulting vector. This A, B. Okay. Now look at over here, brother. As you can see, it is not making a triangle, 90 degree triangle, so that we can calculate it by using Pythagoras theorem. It is not this angle. We are not getting 90 degree. Now look at over. First of all, let's see. This is this formula. To make it 90 degree angle, can we draw another like this? To make this vectors 90 degree, yes we can. So this point, let's say this point is a P, and this point is a Q, and this point is a R. There are 3 points, ending points. This. Now magnitude of this A vector would be, you are familiar with this, magnitude of this vector A would be A. Magnitude of vector C would be C. Magnitude of this vector B would be B. We have understood how to find magnitude of any vector. Just you remove arrow symbol, you will get magnitude. Now we don't know length of this. That's why you can see this. Let's consider it as x. We also don't know length of this imaginary line. So let's say magnitude of this is a y. We can't say that this is equal to this length. No. Okay, both are not equal. Why did we draw this x and y? We did draw this so that we can get a 90 degree triangle. Now we can see this is 90 degree. It is like this 90 degree. You can see. Why do we want 90 degree triangle? We want it so that we can use Pythagoras theorem. Yeah. A square plus b square is equal to c square. Now, two things we can find out from this figure, which is this we are going to consider as a theta, and this will be our alpha. Why alpha? Because this vector is connected to a resulting vector. So this alpha is between a vector and resulting vector. Okay. So this alpha is an angle between a vector and vector C, or you can say A and B. Okay, I hope this part is done. Now two things are coming from this figure, which is this theta. So let's start from sin theta. So sin theta is equal to what? P upon H. Sin theta is equal to perpendicular upon hypotenuse. So what is the perpendicular? We are not talking about this alpha. We are talking about this theta. So this is equal to this sin theta is equal to this upon B. This upon B. So y upon B. Yeah. So y will be I would say this y will be base sine theta. Y will be base sine theta. Can we say? So this is our base sine theta. Now next, cos theta. What about cos theta? So cos theta would be x upon b. X upon b. So this will become x is equal to b cos theta. B cos theta. This two things came from this. Okay, this will help us. This will help us from here to till here. PQ. What is a PQ? P is a combination of a plus x, and QR. QR is a y, and PR is a c. By using Pythagoras theorem, we can say P Q square plus R Q square is equal to PR square. PR square. We can write like that confidently because we are getting 90-degree triangle. That's why. Now, what is the value of a PQ? What is the value of a RQ? What is the value of a PR? Let's substitute all these values. So PQ is nothing but a plus x raised to power 2. RQ is y raised to power 2. PR is also raised to power c. Now here, as we can see, there is a value of x. So value of x is a b cos theta, and value of y is a b sin theta. So we know a plus x is a b cos theta, okay. It is a raised to power square plus y is our b sin theta. It is raised to power 2. C is nothing. This is a c square. That is a c square. This is a c square. Remember, we are using this a, b, c. Why? Because we only want magnitude. That's why, not a direction. So that's why we ignore magnitude. We ignore direction by using mode. Now we can use our algebraic formula, a plus b square. So a square plus b square. Okay. Now plus 2ab cos theta. Okay. Now b square sin square theta is equal to c square. All these terms came by using algebraic method. I would say algebraic. We can write it like that. This we will shift this with this. So a square, we are going to shift this with this because from this two terms we are getting b square as a common. That's why. So b square cos square theta plus again b square sin square theta plus ab hold on, ab cos theta is equal to c square. B square in this two terms are common. So a square, then b square cos square theta plus sin square theta. Then we have a b cos theta. It is equal to c square. As we know that sin square theta plus cos square theta is equal to 1. It is equal to 1 by using trigonometric identity. Trigonometric identity. Now it is becoming a square plus b square plus ab. Hold on. This is a 2ab. 2ab cos theta is equal to c square. This will come in this arrow. This square will be removed. When this will be removed, then of course all these terms will come into handle. So finally we can write this is equal to under root of a square plus b square plus 2ab cos theta. That is how it came, this formula came. That is you can see steps. Remember, this is a resulting. This is our magnitude. Okay, next, what about tan alpha? This tan alpha is equal to b sin theta a plus b cos theta. Let's see how did it come. Look at over. We are talking about this alpha. Okay. To find this angle which is between resulting vector and a vector, so that's why this tan alpha will be equal to p upon b. So here p is y upon, so b, this base completely base, a plus x, this is a plus x. So value of y is b sin theta, and a is as it, x value of x is b cos theta. This is our complete answer. That is how this formula came. This was a derivation. We have seen logic behind this formula. So logic is, this is logic and this is logic. Y upon a plus x. Okay. Just you will have to analyze this figure. You can easily understand that how formula came. This two formula came. Just these figures. I hope we are in the discussion of a triangle. We are observing this by using triangle. Okay, so I hope this part is done. Now let's move ahead of this. Look at this part. Now I want to get a maximum value of a C. I hope this part is done. Now let's see how to get a maximum value of a resulting vector. Look at it. C maximum value of C. Remember, C maximum value we will get when theta is 0. So theta, if we put 0, then we will get maximum value. So in that case, our this will be nothing but 1. I think cos theta is cos 0 is equal to 1. equal to 1. So this 1 came cos theta maximum. We are getting maximum value. So this will be equal to 1 when theta is equal to 0. Okay. Theta will be 0, then we will get a maximum value of C, which will be 1. Which will be 1. Okay. Okay. Now let's see logic behind it. If we put what? Here we are saying that this is C is equal to A plus B. But as you can observe over here, C is not a vector, A is not vector, B is also not vector. All these are magnitude, not vector. Okay, that's why we can't say that these are vector. We are saying that this is C magnitude, this is C scalar is equal to A plus B. What is the logic behind it? How can we say like that? We can say if this C will be equal to A plus B when cos theta, when theta is 0. When theta is 0, just to substitute value over here, this is theta as a 0, you will get this over. So let's see. A square will be as it, B square also, it will be also as it, not 2 AB. So cos theta, it is nothing but 1. Now it is becoming what? Algebraic identity. We can observe algebraic identity. This is this is equal to A square plus A plus B raised to the power 2. So it can be written as A plus B raised to the power 2. As we know, this root will cut this 2. So now it our this thing finally came. This C came as a plus B when we put the value of this theta as a 0. Then this came, this equation. Okay. So this is known as maximum value of a C. Maximum value of a C. Now minimum value. What about the minimum value? To calculate minimum value, we will have to put theta as a 180 degree. 180 degree. So C minimum value will come when we will substitute the value of theta as a 180 degree. As a 180 degree. Then we will get minus 1. So remember, we will have to substitute value of theta as a 180 degree. Then we will get minus 1. So minus 1 is the minimum value of a C. Minimum value of a C. If you substitute value, this minus 1, so this will become logic. So C A square plus B square plus 2AB cos theta. So theta is 180 degree. Okay, theta is 180 degree. So A square plus B square plus 2AB, this will become minus. So this term will become minus. Now as we can see, this is equal to, it is we have right now algebraic identity. So this is equal to A minus B raised to power 2. So this can be written as like that. This is square will cut to 2. Then we will get now A minus B. It is said that A minus B we will write like that by using, it should not be, this should not be, we are getting not direction, we don't have direction, we have a scalar, that's why it should not be negative. She should not be, this value of she should not come as a negative. That's why having this mode will be compulsory with this A minus B. Okay, A minus. If you remove this mode, then sometimes you will get C as a negative value. That's why it is compulsory to apply this mode with A minus B, so that we cannot get a negative value of this is C minimum. Okay, that's why we applied this mode. Okay, so this C is equal to, from this we will get, when we will substitute theta as a 180 degree, then we will get a C minimum value will be equal to, which will be equal to A minus B mod of A minus B. Mod of A minus B. Remember, value of C will be between This will be between uh, a minus b. This is c will be between a minus b, mod of a minus b, and a plus b. Okay, a plus b. This is our range. C will come between this two. Okay, this part is enough. In this part we saw derivation, logic. Now we are going to take some question based on our concept that we discussed in this lecture. During this lecture, let me erase this part. Yeah, number one question is try to understand this question. It is saying if a magnitude of two vector A and B are how much? 10 Newton. Magnitude of this vector is 10 Newton and magnitude of B vector is 20 Newton. Find resultant, which is C vectors of vector A and B if angle between them is given, which is 60 degree, which is 60 degree. So magnitude of two vector, magnitude, can we say that let's say this is a vector A, so A is given, which is a 20 which is a 10 Newton. A is given and B, so magnitude B is given, which is a 20 Newton, which is a 20 Newton. Find the resultant of vector. So between this angle is 60 degree. Between these two vectors are how much angle? 60 degree, and we have to find resultant vector. Resultant. So C resultant. Should we use a formula for this? Yes, formula. Resultant. When it comes to resultant, so this resultant will be equal to a square plus b square plus 2ab cos theta. 2ab cos theta. Look at over here. A is a magnitude. So magnitude is given 10 raised to power square. B is also given 2 multiple 10 multiple 20 multiple cos theta. Theta is given, which is 60 degree. We are using this formula because question is asking resultant of this given two vector. That's why we are using this formula. So resultant is equal to a square under root of a square plus b square plus 2ab cos theta. Cos theta. That's it. So now we have to simplify this 10 raised to power 2. It is equal to 100. 400. 200. 400 again. Cos 60. Cos 60 is equal to 1 by 2. I think so. 1 by 2. 1 by 2. 200. Okay. No problem. 400, 500, 700. No problem. Till here, this is our answer. But if you want to simplify it ahead, you can simplify. You can simplify. Okay. Don't panic. So it can be written as 10 raised to power 10 root of 7. 10 tens are 100. 100 sevens are 700. Now next we have, which is angle between them is 0 degree. No problem. No problem. Magnitude of this is given, which is 10, and B is given, which is 20 Newton. Now C. So A is 10, okay, plus B is 20 square plus 2 again. 2 multiple A is 10, B is 20 multiple cos 0. Again 100, 400 plus 400 multiple 1. So 8, 900. 900. 3 3s are 9. 3 3s are 9. 3 3s are 9. So I think 30. It is perfect. This is perfect square of 30. So 30 is our answer. This is a value of C, which is a scalar, not a vector. Between this is a value of C, magnitude of C. If a magnitude of A is this much, B is this much, so magnitude of C would be 30. 30. Okay, 30. Now next. Now next. Now theta is 90 degree. Theta then is 90 degree. Same magnitude of this would be, to get magnitude of C, we will have to use this formula, which is, as you can see, okay, A is a 10, B is a 20, 10 multiple 20 cos 90, cos 90, 100, 400 plus again 400, cos 90 is 0. This is a 0. Value of cos 90 is 0. Now 100 for 500. Yes, 500. This is our answer. After simplifying this, you will get something number. Now angle is 180. Angle is 180. In this case, nothing is different. Nothing is different. A is a 10 raised to power 2. B is a 20 raised to power 2. 2 will be as it. A is a 10, B is a 20. Cos how much? 180. As you know, cos 180, value of this 180 of cos is equal to minus 1. So this will become 100, this will become 400. Here it will become minus half. This value of this will be minus 1, that's why. So 400, yes, 400. Now this will cut to each other. Finally we got 100. This is a perfect square of a 10. So remember, this will be always positive, not negative. Not negative, because a scalar comes always like positive. Okay, positive. So this C came as a 100. This is our answer. 10, not 100. Now theta is 120. Theta is 120. 120. A is a 10 raised to power 2, B is a 20 raised to power 2, plus 2 multiple 10 multiple 20 multiple cos how much? 120. 100, again 400, 400, again 400. 400, no problem. Cos 120, value of this is equal to minus 1 upon 2. Minus 1 upon 2. Cos 60 is equal to 1 upon 2. So just opposite of this would be minus 1 upon 2. That's it. So 500, then minus 400. It will be 100. 500 minus 400. But hold on. 200. So now 500 minus 200. 300. This is not a perfect square of any number. $300. So 5 will come out. 3 to the 6, 6 5 5 5s are 25. I think it should be our magnitude of the C. That's all in this part.